Hey guys, it's Mr. Dave with the Ray Kitty Science Project, and I am with Ray Kitty Creation Workshop doing the Ray Kitty Science Project to show you guys some fun science and things that you can do at home, as well as maybe learn some concepts with some things you may not have access to, okay? So we're going to be continuing on a little bit from what we did last time. Last time we introduced you to waves, and we showed you how to make this fun little wave bottle, okay, that showed those waves in there. If you haven't seen this, make sure that you check out that last episode and you can see those waves or how to make this little wave bottle. And we showed you our little cup with a drum. We're going to be using this one again today, just a little bit. So for this one, if you do want to make it at home, there's also some fun things you can do with this. All it is saran wrap or plastic wrap, a little rubber band, and a plastic cup. Okay, so when you're working with waves, today we'll be dealing a little bit with sound. So when you're working with waves, this is a fun way to kind of demonstrate. I did resonance last time, but this time we're going to be directly manipulating our little bitty drum there, okay? So that's something that you can have at hand if you want to. You can get that little cup, rubber band, and some saran wrap. Another thing that you may have at home is... this is a little kind of like a dog tag or bead necklace. You can use a heavy string or you can use a necklace. If you are getting into your parents' necklaces and jewelry, make sure they know you're doing it, and please be careful with it so you don't just end up tying it into a knot, okay? But a piece of jewelry, whether it's a necklace, or something like that, will work better because it's got a little bit more weight, okay? So we're going to be demonstrating waves with this guy a little bit too. So if you want to get that necklace handy, if you want to get that saran wrap and that cup, you can get all that stuff. Now, last time we talked about the frequency of waves, okay, which is how often a wave happens, okay? So a wave that happens very fast, hertz is how many times a second that it happens, okay? So we'll be dealing with that a little bit today. If you remember hertz, not hertz like when you come up under the countertop on your head. Okay, not like that kind of hertz, okay? Now that happens to me probably more than you because I don't have anything up here to tell me that that cabinet is coming. Yeah, it is funny. If you have a bald friend or maybe one of your parents have a nice shiny dome like this right here, you will notice they bump their head more. But anyway, that's just a side thing. That's not the hertz we're talking about. Hertz is the frequency. How many times a second that something happens, okay? When we're talking about sound, when we're talking about that type of wave, it happens a lot of times a second, okay? The amplitude is how big it is, okay? Now, we deal every day with waves that are probably a lot larger than you imagine, okay? If you've ever gotten into your car and you turn on the radio and you are listening to, I'm going to give the example of 90, okay? If you were listening to 90.0 on your FM radio, I don't think that's even a station here in Albuquerque, but if you're listening to 90, the size of that wave is actually about 3.3 meters, right? Which is close to 10 feet. That wave is actually almost 10 feet tall that is being transmitted from that tower all the way into your radio, and then that radio decodes that and turns it into sound, okay? Now, if you have a cellular telephone and it is using 5G, right? 5G actually operates on a very, very teensy-weensy or millimeter wave. The wave on a 5G on my telephone right here, the wave that is traveling through the air to make this happen, that wave is actually between 1 and 10 millimeters, okay? So maybe that wave is about as thick as this piece of metal right here. This way. Not this way, okay? So it's a tiny, tiny wave. So the amplification or the volume of the wave is how tall it is, okay? So when we're dealing with waves, the waves that we're dealing with today are going to be a little bit smaller, and you'll see that. We're going to be dealing with a wave called a standing wave, okay? So if you remember a standing wave, when we're working with these, that's a wave that isn't transferring across something, it's working in a single area, Okay, and then we'll be working with our normal waves like we were last time. So when you're working with waves, specifically sound waves, right? Right now, my belly is making my lungs compress and push out air. That pressure is causing my vocal cords to wiggle and produce sound waves, pressure waves from my mouth, gross, that is coming into the microphone of the camera, being recorded, and then that microphone is causing your speakers to wiggle and shoot that sound into your ears, okay? So this little cup here, we're going to use in kind of cooperation with these guys here that we're going to work with today. What I have in here are tuning forks, okay? Now, there are a lot of different frequencies of these tuning forks. Our lower or longer tuning forks are going to produce a smaller frequency, okay? So they're not going to vibrate as quickly as some of our higher tuning forks, so they're going to give us a lower frequency. We're going to whip out a couple of these guys here. We won't need all of them, but we'll get a couple of them. We'll do some of our high pitches and some of our low pitches, okay? So we've got our tuning forks here. Now these tuning forks by themselves don't produce very much energy, okay? We are going to have to use something to help them resonate, right? We talked about resonance last time. So we are going to have something to help them resonate. And we've got this little box here, okay? This little box will help them resonate, okay? Will help them produce more sound. Because when we, I'm going to use a very technical term here, dong, when we dong this little tuning fork here, okay, it makes some sound, but it doesn't make a whole lot of sound. And that's because the only vibration is happening here. Now, that's still a lot of energy, okay? It's here, and then we have some vibration happening here. But when I hit that, okay, these vibrating are what's causing that sound. Now, it may not look like there's very much motion there, but what I want you to think about is waves are energy, okay? Now, that is huge. If all of this stuff here is to show you that waves are energy, if you remember anything, remember that waves are energy. So, when we hit this little thing here, we're causing energy. We're causing those waves. Now, you may not see much motion there, but what's pretty cool is if I get this very scientific device called a ping pong ball on a string, okay? Now this one's fun because it's the Ace of Spades ping pong ball. But when I get this ping pong ball on a string, now this is just a ping pong ball. Yes, I keep saying that just because I enjoy it, but it's a ping pong ball taped to a string, okay? So it's a ping pong ball on a string, and it's going to kind of show us a little bit about the energy that's actually in this, okay? So what I'm going to do is I am going to cause this to vibrate, and then I'm going to bring that little ball up to it. Now, when it's vibrating, you can see that there's actually a lot of energy that is in that little bitty bit of motion, okay? There's a lot of energy there, enough to kind of whack around that big old ping pong ball quite a bit. Now, big, of course, is relative. If this was a basketball, it wouldn't bounce too much. But we're seeing a lot of bounce from that ping pong ball because that little bitty vibration is generating a lot of energy. Now you'll see that sometimes you'll get a nice big bounce, sometimes you just get a little bit of a bounce. It depends on when it's contacting this, okay? So what this is doing is, in a very small scale, it's shaking back and forth, okay? But it's doing it very rapidly, very quickly. This one here, this tuning fork actually shows the frequency, and it is 256 hertz, okay, which is a C. So this is vibrating 256 times every second, okay? So even though it doesn't look like it's doing much, we're getting a lot of motion there, and we could see that when we bonk this ping pong ball with it, okay? So if we wanted it to be a little bit louder, if we wanted a little bit of resonance, we would put it in something that is going to vibrate along with it. Now this, just like we saw when we did our string in the last episode, has particular resonance or particular pitches or frequencies that it'll work better with. So I don't know which one it is. I've got a bunch out here, so let's check. So when I put it on here, you'll notice we get a lot more sound. Okay, so when I hit it, we get a lot more sound when we put it onto our little board here. Now we'll see which ones resonate the best with our particular box. I don't get as much sound. I am increasing the sound. This is vibrating with it, but it isn't as much sound. And this one here is giving us a little bit more. Now maybe a smaller one or a higher frequency will give us more or less. Let's find out. So we're getting pretty good out of this one here. Now, why does that matter, or how do we demonstrate that? Maybe you have seen a big old upright bass guitar, right? Boom, 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 boom. That is a big resonance chamber, okay? That big chamber is tuned to the frequency of the vibration of the strings. I'll show you something with these strings here, or with the string on our ping pong ball. Okay, I'm going to play the guitar on the string on our ping pong ball. Ready? You hear that? I don't either. It's okay. You're not missing anything. I don't hear anything. Okay, this ping pong ball is vibrating a little bit, but we really don't have anything that's giving us very much resonance. Okay, nothing. This isn't vibrating anything. Is this causing sound? But very little, because we don't have anything that is going to resonate that sound. So let me get something here. I have this little flea market guitar. Now, this one, I'm doing the same thing, okay? I am plucking the string just like I did before with that string. It's vibrating just the same, but we have this nice, huge resonance chamber. Now, you can change the pitch of this string. Now, these are set to different pitches. It's not tuned or anything because it is a little flea market guitar. I don't think you can keep it in tune very well, but we're going to hear a little bit here. Ooh, beautiful, isn't it? Isn't that gorgeous? Now, when we turn our little machine here, it will tighten that string, and that will increase the frequency that it's vibrating. Okay, so listen, the more I tighten it, now because it's a flea market guitar, I'm not going too high, but the more I tighten it, the higher it gets. Okay, so you can go lower and higher. Ready? Right, you can get different. When I was a young boy. No, we won't even go there. You don't want to hear me sing. But this here, changing that frequency, changing that tension, gives us a different frequency, and it resonates in our big old box here, okay? So, those waves that we're working with are traveling down something. They have nodes at the end. The node is the little part, the valley in the wave, okay? That's the node, right? That's that little part, the low part in our wave, right? The antinode is the high point in that wave. So those waves are, again, that transverse wave that's following down that material, okay? So what we're going to show with these ones here is we're going to show a little bit different kind of wave. Now, before we do, I forgot to show you our cup. We have our cup here. Now this, what you can do if you make this little cup, it's a very poor drum. Yeah, you get a little bit there, but not much. But if we get something that is vibrating, okay, if we have something that's already giving us a frequency, let me see, we can vibrate that material, and it gives us a nice speaker. Okay. Now, in a future episode, we're actually going to build an electric speaker out of a cup like this that works just like the speaker in your car or whatever. I'll show you how to build one of those a little bit later. But for now, we're just showing that that sound is resonating in here because I'm physically touching it. Okay, so it's not resonating with the air or the material in the air. I'm actually touching it for this one here. But we're showing how this can vibrate this and cause more sound. Okay, so that was the little tie-in with your little baby cup. Now, another way to show those waves that we're working with is with that necklace. Remember how I told you we're going to work with a little necklace or a piece of jewelry? Before we move on to our standing waves, we're going to use this to demonstrate those waves on our table here. Now, this is a good way if you're wanting to take it a little bit further into actually getting your measurement of waves. If you want to do some of the math on how the wave works, okay? We're going to be working with a transverse wave because we're going to go across our material, okay? With this one here, if you do it on a giant piece of paper or even a regular sized piece of paper and you create your wave, then you can trace that wave and you can measure how many waves are in your wave cycle. So let me show you those waves here, okay? Look at that. Now what we're doing is we're making that little like bead snake there, okay? We're shooting that wave across the material, and as it's going across the material, we were talking about centipedes earlier, and right now this thing is grossing me out because now I'm thinking of centipedes. But as we're going across this material, we can see that it's making those waves. Now if you were to stop, okay, now you can measure that wave. And so you can do a little bit of fun math with this one here if you want to take that over into math. I like science. I'm not a big math guy. But there's math there in the wave, or you can just count the waves, or you can see how the energy, right? We have high energy at this end where it's happening, and how that energy depletes as it's going along our material, okay? Just like if you are yelling at your brother or your sister and you're on this side of the house and you're like, why did you steal my tennis shoes? And I don't know why you all of a sudden have a strange accent, but you're yelling at your brother or sister across the way, why'd you steal my tennis shoes? Now they're all the way across the house. They're like, what? Why'd you steal? Now you're yelling over here. There's a lot of that energy. But by the time we get over there, that energy has dissipated, right? It has been interfered with the atmosphere and all kinds of fun things. So that's a fun one you can do with those chains if you want to get a little bit deeper into the science of waves, okay? So we're going to change gears just a little bit here, and we're going to go from talking about those waves that are moving across a material to what is called a standing wave, okay? Now, a standing wave is referring to a wave that isn't being transferred across a material, but in the material itself, okay? So what we have here is a little bitty wire, okay? You can see that little wire there, and the wire is a hoop. It's a little circle, okay? So what we're going to do is we're going to turn on our wave generator that we had before, and we're going to look at the waves on this, and then we're going to work on our Chladni plates in a minute. And I didn't like stutter there. It's Chladni. It's a German word. That's just what they're called. All right, so when we turn this on here, you see that our wave there is actually changing shape, okay? Is it better on the, let's see. Yeah, so we'll do, so when we're looking at this here, you can see that as we change the frequency, we're changing the shape of that wave, okay? So the higher the frequency, the different that those nodes are going to show up on our plate there, okay? So this is a standing wave, and I'm going to show you kind of a lot more dramatic way of seeing that in a second here, but I want you to have the idea of the standing wave is something that's staying in one spot and moving back and forth in that spot rather than traveling across, okay? So we're going to put our plates on here. I'm going to turn this thing off. These Chladni plates, okay, Chladini, are just a metal plate that we're going to put onto our little vibration generator, okay? Now, last time I didn't get too much into what's going on here, but this is a sine wave generator, like we talked about. It generates that nice smooth wave, and it translates it into this machine here. This is essentially like the spider on a speaker, okay? This is like a speaker, but instead of having a cone, this has a little rod here. And that rod is moving up and down and up and down. And that is what is generating our waves. So that's what generated it across the string in the last episode. On this one here, it is what is going to be moving our plate up and down and up and down and up and down. Now, I'm going to put this on a couple paper towels because we're going to have some sand on here. Okay. Now, this is a very like salt-like sand, or if you imagine about that size. And we're going to put that on our plates, and we're going to show you a little bit of those waves in a standing wave, a fun thing that waves do in the material. Now, this is actually something that may look strange, but it's happening around you all the time. So I'm going to put a plate on here. This is our circular plate. Make sure it's nice and tight. I'm going to put that on there. Now, you may remember this plate from when we did the oobleck on the plate and it danced around on there. Now, we're going to do the same here, except we're going to put a little bit of salt on there, or a little bit of this sand, okay? So I'm going to turn on my frequency generator. I'm going to turn it to about half of the amplitude, or half of that wave size, meaning this is moving about halfway across its little axis there, or as much as it can move, okay? Now we're going to put some of this salt on there, and I'm going to put some in the center. Now you can see that it kind of just coats that plate, okay? That's what we're after. You can see it not moving around too much, but that's going to change when we change our frequency, okay? So I'm going to increase the frequency. I'll try not to get my hand in the way there, but every once in a while you can kind of check in, or I'll let you know what frequency we're at. Now when I was here, I'm right at 34, and we see a little bit of motion around the outside on that plate. So I'm going to increase that frequency. Oh, we've come to a resonance with something else on the table that is now vibrating. There you go. Now something is happening with our salt. If you look here, we now have got a pattern on our plate. If you can see on that tray there, that all of those little grains are now going into a pattern. Okay? So instead of being random on there, we can see two lines down our tray. They look like maybe like the little lines on the Hurley symbol or something like that. And that is at that frequency. When I change that frequency, they'll break up, okay, until they find another frequency that's going to make them move around. So you see them dancing around again? Now we're coming in. We have a nice little almost circle pattern. We'll put some more of those on there. There you go. Now look, we have two almost parallel lines going the opposite direction. Now what's happening here is this plate is vibrating, but it is a standing wave, meaning it's not vibrating across the material, it's only vibrating on the plate itself, on the tray itself, okay? So let's see, I'll turn it down just a little bit, maybe see if we can see those lines a little bit better. Oh, there you go, look at that. Now you can see as I'm pouring it on here, it's dancing around and it's leaving area, but now we have this nice little like oval going on our tray here. So it's going to change based on the frequency because that's going to vibrate that plate differently. So we went from an oval to a line, and all I'm doing is I'm increasing the frequency, okay? So it's vibrating faster and slower. Now we have just kind of a crazy mess, and there are a couple nodes there. Remember, the node is still that point that's not moving as much. That's why that salt is staying still in certain points, because that tray isn't moving very much on those points. So let's see, I think we've got a good shape here. What are we going to have? We can see a nice little area that's happening. This is at 122 hertz. We have a nice big circle around there. So this is our node, okay? This is the part where the plate is not vibrating too much. This part here, where you don't see any salt, is because that plate is vibrating like crazy and moving it around. So let's get to some high frequencies here and see if we can move it around. We're going to go way up. I'm at 163 now. And we'll see that pattern change just a little bit. There you go. So I'm at 217, and we're seeing something happening here. And that salt is moving around. We're getting, now you'll notice the pitch changing, right? So it's getting a higher and higher frequency. We have almost like a little smiley face going on there now. Okay, so let's put some more on there, see how we're doing. You can see that stuff dancing around. And see, so our antinode or our crest is where we're getting this strange little movement of this salt here as it's all bouncing around. And then our nodes or our still points are the points here that aren't moving, okay? So, or they're not moving as much. So what's happening here is this is a standing wave. So this wave here ends and begins here, and it stays in this material. And it'll stay in this material here. And so let's see if we can get another fun shape. There you go. So now, if you look, I'm going to see if I can wiggle that salt this way just a tad. There you go, so you can see a little better. As it's falling off, you'll see the parts that are actually sticking to that plate. We have these nice waves that are going around the outside, okay? So let me change the frequency just a little bit here. And remember, this is a standing wave. So I upped the frequency up to 231, and I'll put a little bit more salt on there. And I'm going to do the same. I'm going to just kind of tilt it towards you so you can see what's happening there. You'll see as I'm pouring it, it almost seems like it's catching right here, okay? That's not because there's something on this tray catching it, but this point here is vibrating very quickly. This point here is vibrating very quickly. The parts where it's black are really giving us some movement. The parts where that salt is staying in that little resting point, okay? So this is a standing wave. Now this is all done on a circle here. You can see now we have these little points that are coming out at this frequency. Now a round plate is going to work differently than a square plate, okay? Now I'm going to turn it up just a little bit here and see if we can get a different, there you go. Now you can see here, you saw as soon as I crossed that one threshold that it changed again, okay? So let's see what we've got here. If we put some more salt on there, now we've got two nice circles. I'm going to turn it down just a little bit so it's not driving the speakers crazy here. So we see that nice circle there. Even as I turn it, it's holding on, it's gripping on here because this is knocking that salt back and forth. So I'm going to turn that off for a minute. Ah, that's nice. And we are going to change to our other square plate, okay? So we're going to look at a wave on a square plate rather than that circle. So we're going to do the same thing. I'll start here when it begins. We're going to be down at 30 hertz again, which is very slow, okay? That's, well, relatively slow. It's still 30 times every second, but it is a lot slower than we were going before. So this is at 30 times a second. I'm going to put some of that salt on there, okay, or sand on there. And we're going to turn it up just a tad. And you see some vibration around the outside, but not too awful much going on. You'll notice that it wants to stay in that center, okay? So let's up that frequency. I'm going to turn down the amplification just a little bit. We're going to up the frequency, and you'll see as soon, okay, when I slow it down, this is all pretty still. When I turn it up, right here in the center, you see that? That start to dancing around in the middle there. Now we have, you can see as it's falling off that it really wants to stay on these parts right here, okay? And that's because that is that node. That's that slow part on there, okay? So this is a standing wave. Let's hit a high frequency real quick before we wrap it up on that one. Now you can see when I turn it down, watch how it changes, okay, ready? So now you see that nice little X there. Now when I turn it up just a little bit, it changes to this way. Okay, down we'll go this way. Now our salt is kind of eventually coming off, but now we have these straight lines this way. When I turn it up, our wave is now going across this way, okay? So that is a standing wave, and what is happening is the same thing as in a long wave that's going across something, except it's staying in the one spot. So our nodes are the small points, and then our peaks or our antinodes are the big points, okay? Now, I have something I'm going to try here to end this up, and this one here, I like to say that it is an experiment, okay? So if you've ever been in one of the Ray Kitty classes or anything like that, you'll know that we sometimes do demonstrations and we sometimes do experiments, okay? A demonstration is something that you know is going to work. an experiment is something that works most of the time. Okay, so we're going to do is these are called singing rods. Okay. Now these singing rods are going to show us a little bit of what happens when you combine that weird little standing wave with that long wave. Okay. And when we do it here, I'm not going to go too crazy with it because these can get crazy loud. Also, they can actually get to a dangerous loud point, but we're not going to do that. We're just going to do a little bit here. And I'm going to work with all three of these. Now I have some shorter ones, some longer ones, and a hollow one. And I'm going to put something on my hands first that is rosin. Okay, rosin is the stuff that they'll use like on a bow. Okay, the bow for a violin, not a like archery bow. But I'm going to put this stuff on my fingers, so you're going to see some nice sticky stuff on my fingers, and that is to make my fingers sticky. Okay, so we're going to make my fingers sticky, and then we are going to work with this one here. This is a solid one. What I'm going to do is I'm going to begin a vibration with it. Okay, just get a little bit going. It won't be much. You'll probably hardly be able to hear it. Okay, I just have a small vibration. Now that vibration is an up and down vibration. What I'm going to try and do is change it into a nice little circular vibration, or like a Doppler, like you would see on the weather. Okay, so to do that, I'm going to rub my fingers down the rod. That's as many times as I'll do it. I won't go any higher than that. If you continue, that's going to continue to get louder and louder, okay? And it will get to, I mean, like a point where like the dogs in the neighborhood are like freaking out. But what happened there was we just changed that energy from up and down to a nice circle, okay? Just like we did here, okay? So today we talked about waves. Today we talked about standing waves, transverse waves, all different kinds of waves. If you want to see some more, be sure to check us out next time. I'm Mr. Dave, and don't forget that science shows you matter.